Hello, everyone. Hello. Hello.
Hello, hello, hello. Hello. Hello.
Hello. Yeah, I guess now I am audible. So here we know that tan alpha plus tan beta will be equals to root 2 tan alpha. Here we know that tan alpha plus tan beta will be equals to root 2 of lambda upon k plus 1, and tan alpha tan beta will be k minus 1 upon k plus 1, right? Tan alpha tan beta will be k minus 1 upon k plus k plus 1, right? So we have been given that tan square alpha plus beta is equals to 50, correct? So if tan square alpha plus beta is 50, then we will just substitute tan of alpha plus beta. What is tan of alpha plus beta? Tan of alpha plus tan square alpha plus beta will be tan alpha plus tan beta upon 1 minus tan alpha tan beta whole square, right? So we already know the value of tan alpha plus tan beta. It will be 2 upon k plus 1 upon k minus 1 upon, sorry, 1 minus of k minus 1 upon k plus 1 whole square, and this value is given to us as 50, and this value is given to us as 50. So try to solve this. Like when we try to solve this, we will get root 2 lambda upon k plus 1 in whole square into, see, 1 minus k minus 1. Here I am doing that calculation. 1 minus of k minus 1 upon k plus 1 will be k plus 1 minus of k plus 1 upon k plus 1. Right? So this will ultimately k gets cancelled and this will become 2 upon k plus 1. Correct? So the answer is 2 upon k plus 1. So can I take that in the numerator and do the square, right? So this value is given to us as 50 again. Now the next step here is k plus 1 whole square. K plus 1 whole square gets cancelled. Root 2 lambda square. Root 2 lambda square will become 2 lambda square, and 2 square will be 4 over here. You will get 50. So lambda value from this equation can be derived as 10, right? So the value of lambda is equal to 10. Okay. Now let's try to solve the next question. Here it has been given to us that there is a quadratic polynomial. Let us assume that quadratic polynomial to be ax square plus bx plus c. Okay, this is our quadratic polynomial. So f of x has been given to us as a quadratic polynomial, and the information is f of minus 1 plus f of 2 is equals to 0, right? So this we already know that one root is 3, right? One root of this equation is given to us as 3. Okay, so when one root is given to us as 3, can I write this equation as x minus 3 into x minus a root k equals to 0? So can I write this equation like this? correct? If 3 is the root of this equation, that means x minus 3 is a factor. Now f of minus 1 plus f of 2 is 0. So from this we can find out that what is the value of k. First find f of minus 1 plus f of 2 will become what? I'll substitute x as minus 1. It will become minus 1 minus 3, and here it will be minus 1 minus k. Okay, so this will become minus 4 times minus 1 minus k. This will be 4 times k plus 1. Okay. Hello. Hello. Yeah. So the value is 4 times k plus 1. So the value is 4 times k plus 1 for f of minus 1. Now f of 2 will become what? I'll substitute x equals to 2 in place of minus 1. It will become 2 minus 3 into, so this is all also our f of x. Okay. So let's discard this assumption and use this one. Now 2 minus 3 into 2 minus k equals to what we will get here is 2 minus 3 is minus 1 and 2 minus k is 2 minus k. So can I write this as k minus 2? Now the sum of these two quantities is 0. So 4k plus 4 plus k minus 2 is given to us as 0. Then here we will get 5k plus 2 is 0. K value comes out to be minus 2 upon 5. So the other root of this quadratic equation is minus 2 by 5, right? So which is the interval where minus 2 by 5 is lying? So the answer is option A. Okay. I hope this was clear to all of you. Let's move ahead. Now, now the question over here is the set of all real values of lambda, the set of all real values of lambda for which the quadratic equation lambda square plus 1 into x square minus 4 lambda x plus 2 equals to 0 always has exactly one root in the interval 0 comma 1. So first of all, can I say that lambda square plus 1 is always positive? So our a is always positive, right? Since this is 1 plus the square of some constant. So this our a is positive. So this quadratic equation will have an upward parabolic graph. So let's try to interpret something from the graph. 0 comma 1 is there and always one root is supposed to lie in this interval. So I will have to draw the graph like this. Okay, one is this scenario and the other scenario is going to be like this, right? Right. So in both the scenarios, can you see that f of 0 in the first scenario, f of 0 is positive with above the x-axis and f of 1 is negative, right? And in the second scenario, f of 0 is negative and f of 1 is positive. So the cumulative result that is true for both the scenarios is that f of 0 into f of 1 is negative, right? And one more thing that we also have to check is that discriminant discriminant should be greater than 0, right? Since exactly one root is lying between 0 comma 1, that means other root will lie somewhere else and then both roots will be distinct. So d greater than 0 is going to be our another condition. Okay. So we will check for both the condition and solve this question. So here, from here you can find out that discriminant is always gonna be greater than 0. How? See, discriminant what what will be the value of discriminant? The value of discriminant is 4 lambda whole square b square minus 4 into a into c. Okay, so this will be 16 lambda square minus 4 lambda, sorry, 8 lambda square plus 8. So this will be 8 lambda square plus 8. So here from this it is clear that our discriminant is always going to be positive. So the lambda can be all real number. Okay, from first condition. From the second condition, f of 0 into f of 1 is negative. What will be f of 0? The f of 0 is 2, right? And f of 1 is lambda square plus 1 minus 4 lambda plus 2 should be less than 0, right? So here you get, since 2 is positive, you can cancel it out and you will get lambda square minus 4 lambda plus 3 should be less than 0. So if from here you will get lambda minus 1 into lambda minus 3 should be less than 0. So lambda will lie between 1, 2, 3. Okay. All right. Here it should be 1, 2, 3. 3 should be open interval here. Why? Because f of 1 and f of 0 can never be 0, right? If those are here, it is given that 0 comma 1 is open interval, so we cannot have the root on either 0 or 1. So if one root is lying in between, the other root will lie away, like outside 0 1. So that is why we cannot have this equality sign here, and hence 1 comma 3 open interval is the correct answer. Here also, if you see in this, here the solution, in the explanation to this solution, here this equality sign shouldn't be there, because f of 0 and f of 1, f of 0 is never going to be 0 and f of 1 is also never going to be 0. That is what the condition has been given to us, right? No, it can be 0 actually. Okay, this is correct. This is correct. So the answer is option D. Now there are two positive numbers p and q such that p plus q is 2 and p power 4 plus q power 4 is given as 272. Find the quadratic equation whose roots are p and q. Okay, so let's try to solve this question. Here p power 4 plus q power 4 is given as 272. Now can I write p power 4 plus q power 4 as p square plus q square whole square minus 2p square q square equals to 272, right? And here I can write p square plus q square, we can be written as p plus q whole square minus 2pq, and here it was whole square minus 2pq equals to 272. Now, what we are supposed to do is p plus q value is given to us as 2, right? So can I write here 4 minus, I am taking let t equals to pq, right? So this will become 4 minus 2t whole square minus 2t equals to 272. So this will become what? 4t square plus 16 minus 16t minus 2t equals to 272. So this quadratic equation will become 4t square minus 18t minus 256 equals to 0. So reducing it further, we will get 90 minus 128 is equals to 0. So here you can see 128 into 2 is 256. So can we get 256 uh, as the product and 9 as the sum? Here it is 2p square, here it will be 2t square. So just wait, there has been a calculation mistake here. So this will become 40 square minus 16t plus 16 plus 16 minus 2t square equals to 272. So this will become 2t square minus 16t plus 256 equals to 0. So this can be written as t square minus 8 plus 128 equals to 0. So we know that 16 8 is 128. So we can write t minus 16 into t plus 8 equals to 0. So here from here you get value of PQ as 16 or minus 8, right? So we have to reject this value and take 16 as the product of P and Q, because there are two positive numbers P and Q. It is given in the question. So the product cannot be negative. Hence the product is 16. Now we know that uh, sum of P and Q is 2 and product is 16. So we have to find a quadratic equation whose roots are P and Q. So what we will do, we know, can we write that quadratic equation as x square minus of p plus q times x plus pq equals to 0. So this will become x square minus 2x plus 16 equals to 0. So this will be our answer. Now, in this question, here see what has been given to us. See, first of all, e power this is a root of the equation. Okay. Then we have to find the value of sin theta upon sin theta plus root 3 cos theta. So e power sum of cos square theta cos power 4 theta up to infinity will be how much? Cos square theta plus cos power 4 theta plus dot 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 ln 2 can be written as, see, this is a GP, this is a GP. So here the sum of infinite GP when the common ratio is less than 1 is given as cos square theta upon 1 minus cos square theta, right? And ln 2 is already there. So we already know this will become what? This is cot square theta, right? E power ln 2 power cot square theta. So e power ln x is x, right? So this will become 2 power cot square theta. Okay, so this is the root of the equation. So a root of this equation is t minus 9 into t minus 8 into t minus 1 equals to 0. So first of all, cot square theta should be equals to 0 for 2 power cot square theta to be equals to 1, right? And other root is 8. So 2 power cot square theta is equals to 8. So that means cot square theta is 3, correct? So the value of cot square theta is 0 and the value of cot square theta is 3. So cot square theta can never be 0 in this given interval, right? When theta is pi by 2, then cot square theta is 0. But this is not included in the interval. Hence, cot square theta will be, the value of cot square theta will be 3 and the value of cot theta will be root 3, right? Why the value of cot theta will be root 3? Because in the interval 0 to pi by 2, which is first quadrant, all our trigonometric ratios have positive values. So cot theta is root 3 when cot theta is root 3. Cot theta is root 3 when theta is 30 degree. So the value of sine theta is half upon half plus root 3 into root 3 by 2. So this will become 2 will get cancelled. 1 upon 1 plus 3. So this will become 1 upon 4. Right? Here we can see that the answer is 1 upon 4. Okay. The answer given to us in this should be 1 upon 4. Now the least value of alpha such that this equation has at least one solution in 0 to pi by 2. So can you guys think about this question? Yeah. Can I write this as 4 upon let sin x be equals to t. So can I write this equation as 4 upon t plus 1 upon 1 minus t is equals to y. Alright. So what will this become? 4 minus 40 plus t upon t minus t square. Right. This will be y or alpha which is given. You can assume any value. This will become 4 minus 3t upon t minus t square equals to alpha. Right? Now, I am going to differentiate this to find the minimum value. So first of all, dy by or d alpha by dt will be what? D alpha by dt will come out to be minus 3 into t minus t square minus of 1 minus 2t into 4 minus 3t. Right? So when we solve this upon the denominator square. So when we solve this for equal to 0, when you solve this for equal to 0, the numerator should be 0, right? So for numerator to be 0, you will solve minus 3 into t minus t square minus 1 minus 2t into 4 minus 3t equals to 0. So after you solve this equation, you will get something like 3t square minus 80 plus 4 equals to 0. So the value of t will come out to be 2 by 3, right? So sin 2 by 3 or one more value we will get. You will get t value as 2. So since we have assumed t equals to sin x, since we have assumed t equals to sin x, this t cannot be equal to 2, and hence we will have to take sin x equals to 2 by 3. So sin x equals to 2 by 3 is our answer. So when sin x is 2 by 3, we are getting the least value. So we will substitute here 4 upon 2 by 3 plus 1 upon 1 minus 2 by 3. So we will get 12 by 2 plus this will become 3 by 1 equals to alpha. So alpha will come out to be 9. Hence the least value of alpha is 9 in that given interval. Now the coefficient of ABC of quadratic equation ax square plus bx plus c are obtained by throwing a dice. The probability that it has equal roots is okay. So to have equal roots, we know that b square minus 4ac b square minus 4ac should be equals to 0, which means b square should be equals to 4ac. Okay, which means b square should be equal to 4ac. So when like we'll have to do trial and error, when b is equals to 1, ac value is 1 by 4, which is not possible, right? When b value is 2, ac value is AC value is 1, right? This is possible when A is equals to 1 and C is also equals to 1, right? When B value is 3, AC value comes out to be 9 by 4, which is again not possible. But when B value is 4, AC value comes out to be 16. So 16 is possible for 4 into 4, right? So 4, 4. A and C can be 4 and sorry, AC value comes out to be 4. 4 AC is 16. 4 AC is 16. So AC value will be 4. Hence 1 comma 4, 4 comma 1, 2 comma 2 are all the possible values for A and C. And when B value is 5, we get AC value is 25 by 4, which is again not possible. When B value is 6, AC value is 9. For to get 9, we need 3 and 3, right? So the number of possible situations for A and C are here we get 1, here we are getting 3, here we are getting 1. So it is 5, right? So 5 total number of possible outcomes upon total number of outcomes, right? Since we are supposed to roll for 3 variables, the total number of outcome will be 5 upon 216, right? So the answer is 5 upon 216. Now here in this question, alpha beta is given to us as the roots of the quadratic equation. Alpha beta is given to us as the roots of the quadratic equation this. So can I write so I think this is an incomplete question. This question is incomplete here. Let's try to solve the other question. The integer k for which the inequality is valid for every x in R is. So we know here it has been given to us that a quadratic equation should always be greater than 0. When is this possible? When this will happen is when A is positive and D is negative. So for D negative, we will check the conditions. What do we get here is that D is B square minus 4AC. So 2 into 3K minus 1 whole square minus 4 into A into C should be negative. So here you will get 4 into 3K minus 1 square minus 32K square less than 0. So 4 into 9K square minus 6K plus 1 minus 32K square should be less than 0. So you will get 36K square minus 24K plus 4 minus 32K square less than 0. Here you will get 36K square minus 32K square will be 4K square minus 24K plus 4 less than 0. So K square minus 6K plus 1 less than 0. Right? So here what can be the roots? Okay, here we missed the 7. So 8K square minus 7 will be also there. 32K square plus 28 will come. Here plus 28 plus 28 plus 28 should be less than 0. So this is for k square minus 6k plus 8 less than 0. So here after this step k square minus 6k plus 8 less than 0, what I'll do is k minus 2 into k minus 4 should be less than 0. So k will lie between 2 to 4, right? So the integer k in between 2 to 4 is only 3, right? Hence the answer is 3. Okay guys, so this was all about today's session. I hope you had a good class. There were some mistakes in typing, so let's ignore that and try to understand the concept. Have a good day. Bye bye.